Okay, so what we've got sorted out is at least this aspect of U. So that's sorted out. Now we can ask ourselves, remember when we applied the weighted digital method, that weak form, when we start looking at that weak form. The one question I want to ask you is, what was the one thing that we had to assume in addition to the displacement field? Can you recall? It was essentially the weighting function. Yeah? So I want to talk now quickly about what is our weighting function going to look like. Our weighting function. So we've got a U field as a function of psi. What would my W field be as a function of psi? Okay. What would this weighting, and let's call it weighting function for U. What would that look like? Well, can you recall what was the one condition I said we must always satisfy with those weighting functions, because we're doing the Bibner-Gilligan approach, is the fact that this weighting function, which is now associated with the U displacement field, must have the same form, just different variables. Okay, so this weighting function field will look as follows: N1 psi, but now I'll call it W1. Okay, maybe WU1 plus N2 psi W2 plus N3 psi WU3. Okay, and this is essentially the choices we need to just make sure we will follow. Once you've chosen the displacement field, what will follow is what is the form of the weighting function. Okay, that is important to understand. So this is now one field, another field. There's one big thing that's now missing. This is world lives between -1 and 1. Okay. The big thing that's still missing is, what do we do with x? Okay. What do we do with x? What is the relationship between x and psi? This is still the one big thing that we need to talk about. Okay. So first off, the relationship between x and psi. There's various ways we can go about this, but the one approach that we'll follow is going to be the finite element way, is going to be what's called the isoparametric formulation. Formulation. A very long word for something very simple. Okay? I promise you, it's an extremely long word, and the concept is as simple as what I've just explained here. Each of these nodes, okay, and this world psi minus 1, psi equals to 1, and psi equals to 0. I know for a fact that in the real world, in this X global system, okay, this might be somewhere here, okay, in its X place. That this node has got an X coordinate of X1, this node's got an X coordinate of X2, this node's got an X coordinate of X3. Okay, so all I want to do is to say, well, okay, I know that this node's X coordinate is X1, this node's X coordinate is X2, and this node's X coordinate is X3. What we're going to do with the isoparametric formulation is just as simple as this. I'm going to say x as a function of psi. It's going to be taking as what? Yes, you've guessed it. Yeah, I'm going to just say it's n1 psi times its x coordinate plus n2 psi and its x coordinate plus n3 psi and its x coordinate. And now you can give me any psi, and I'll tell you what its x coordinate. You see that? What is more important, I can now go and say, I can go and compute the derivatives as well. dx d psi. And I can differentiate this expression. Yeah? And now I know how to relate x to psi. Okay. So what is the time on this one? 4 minutes. So what I'll do is, I will stop this video and then we continue on with this geometric interpretation. Let's look then at stuff like, if you were to differentiate this, what would this come to? Okay. I'm just going to maybe clean the board that we just started with, with a clean slate. But now you understand we've made a choice for N1. We've got the weighting function. We've sorted that out. We have sorted out the geometry. And I tell you, this isoparametric formulation, if it wasn't for this, the finite element method would still be very, very much in development. This was one of the big breakthroughs that happened in the sort of, I'm talking about the correction here, but in the 60s. That really, or early 70s even, that really made sure that the finite element method was able to was really coming to its fruition and was really easy to code and implement in a very systematic way. So isoparametric formulation, it's a small step, a small piece of insight, but it's a really, really important one, because people were mapping things between X and psi in very archaic ways until this came in, and then this really bloomed the automation of finite elements and development of rapid development of finite element software. Okay, so this is hopefully going to give you a good idea of what's going on. Let's do in the next video, let's look at this.